stuff. Let's get everything running on Twitch, TikTok, YouTube. Yeah. All good people ask questions in text. Yeah. The issue I have with that is when students ask me questions with text, they usually type it wrong, or I can't see what their teacher was actually trying to ask them and stuff. And so I just tell students, I'm like, hey man, just send me a screenshot, please. I can find out in about 20 seconds what grade level you're at, what you need to know, and like how to teach it to you. Text becomes just like kind of difficult. All right, let's activate YouTube. Would you keep doing this even if you retired? Retired from what? I don't currently have a job. I mean, I teach privately regardless. But yeah, I think I would continue to keep doing this. Okay, and also I know. Thank you, whoever was yelling at me on my Twitch, on my TikTok, saying my sound levels were super low. I realized for the last month my sound levels have been like inaudible. It was ridiculously gained down, so I had to fix that. All right. I don't know if we're gonna get TikTok chat to work at some point. Whatever. Fuck it. We do have a solution from. Oh, yeah, no. I was teaching at and believe me, I would love to keep teaching at UCLA, but everything university right now is getting like seriously screwed. I taught 2 quarters at UCLA, and then I was going to teach this quarter, and then they told me that they don't have any money. But they said check back next year. So maybe. I really did enjoy teaching. It was fun. What's up, Sib? Good to see YouTube's working. Okay. Also, Sib, if you have a question, please submit one. I would love to. We don't have that many people who have questions here so far. And now we have a new queue system, so you can see whose question I've been working on. Yeah. This appears to be problematic. Yeah. Consider the curve parameterized by this. Wow. Find the point where the line tangent to R at t equals 1 intersects the YZ plane. ln negative 1's going to come up? Uh-oh. That's scary. I hope it doesn't. Okay. So, I don't know. We could write this, right? I could write R as equal to, like, an initial point, which is going to be 1, 0, 0, I guess, right? And then plus something as a factor of t, which is just going to be 1, oh, I see. Actually, we got to leave it like this, sorry. So t, t squared, ln of t. At least we know these parts don't depend on t, right? So they're breezy. It intersects the YZ plane, yeah. To r of t at t equals... Wait, find the point where the line tangent to r of t at t equals 1 intersects the y. So first we got to find the line tangent to r of t at t equals 1. I kind of did, right? I did this like 1 plus t, and then this is 0 plus t squared, and then this is 0 plus ln of t. I don't know, I feel like it's easier to see the constants, because now r prime of t, I know this just like goes away, because none of that shit depends on t. So this is just 1 comma 2t comma derivative of ln of t is 1 over t, right? If I remembered correctly. I'll take it. Nice. Justin got a question too. Thank you, Justin. Look at that. See? Now it gets added to the queue. See? Now we have a queue. Okay. Cool. And at t equals 1, that means r prime of t, r prime of 1 is going to be equal to 1, 2, 1. Okay. But that's a derivative. So then the line tangent to that, right, has to be r prime of, well, let's call that like, let's call this whole thing here just like g of t, maybe, yeah? So g of t is going to be equal to, so it's going to have this slope, right? 1, 2, 1. And it has to go through R1. I agree, right. And so if it goes through R1, that has to be 2, comma 1, comma 0, right? Do you agree with this so far? I think this is the equation of the line tangent to R of t at t equals 1. But now we have to figure out where it intersects the YZ plane. And intersecting the YZ plane, sometimes I gotta draw pictures. I'm a very visual person. You think it happens at t equals -2? We'll see. So if this is x, this is y, and this is z, this is the YZ plane. So the YZ plane is where x equals 0. Oh, perfect. Okay. So yeah, you're right. That is going to be where this is -2. So YZ plane is where you have 0, comma y, comma z. And that occurs when t is at equal to -2, right? Because watch. So g of -2 is equal to 2, comma 1, comma 0 plus, and then that's going to be 1, comma 2, comma 1, -2. So 2 plus -2, that's going to be 0. Love that. And then that's going to be 1 minus 4, which is -3. Do it on GeoGebra just for fun. Yeah, we can check it out. And then this is going to be -2. So I think this is the point. I believe that's it. We can check that if we want. Let's see. Throw it at my favorite ChatGPT. Just tell it to solve it. And actually, I think we can probably do this actually on 4.0, honestly. I don't like the new models. Someone told me the new Sonnet model is super dope. The Claude model. Let's just see if it does that. Drawing curves in 3D is always painful. I agree. Yeah, it does suck. Yeah, it's a major pain in the ass. But okay, cool. Let's see. Well, come on, GPT 4.0. You're a fast algorithm. You're not one of these slow algorithms. Yes, we're given. Okay, cool, awesome, nice. I always like to just see the process of how it does it, to see if it's similar to how we did it. So far looks good. Yeah, and look at that final answer. 0, -3, -2, which is exactly what we have. So we did it. Congrats, and good job.
Good job. Well done.
Nice. Cool. All right. So now here's the cool thing. I'm gonna go into my admin console. I'm gonna mark that one as done. Let's see if it changes it on the thing. I think it did. Yeah. So here, and yeah, the queue changed. Wow, look at that. Look at that. Isn't that dope? That's so cool. Vibes. Nice. Okay. Next question comes from Justin. Ooh, fluid force. Ooh, no. Justin, you asked me a tough one here. Okay. Calculate the fluid force on one side of the plate using the coordinate system shown below. Assume that the density of water is in... I get so upset. What, pound per feet cube? No. I want like newtons per meter cubed. What? Pounds per feet cubed? Oh, that's annoying. RK says, is there a specific pattern I could follow to factor things? Depends what types of things are you trying to factor? Like polynomials? I have a couple videos on how to factor things when the first coefficient isn't 1 versus like when it is. There are different tricks on like how you can factor things. If you want to if you want to submit a screenshot of like a specific thing you need help with trying to factor, I can show you some tricks for it. There's a website down there. Just go check it out. Okay. I remember how like force works. Let's see. I know for fluids, right, that you have like a force of gravity. And it's interesting because pressure, like force acts in all areas. This is actually a really cool thing about it. Here, let me show you. Pressure in liquids. Yeah. It acts in like all different directions. I think I kind of want to like show this. Right. Static fluid pressure does not depend on the shape, total mass, or surface area of the liquid. It's just the pressure is what it is. But then pressure is also equal to force over area. So I think what we end up doing is that the force is equal to the pressure times the area. Yeah. Dun-dun. Yeah. And it's like out on all sides, I think is how it is. Right, yeah. Okay, so let's try to do this question then. So, calculate the force on one side of the plate. So this is the surface of the pool. This is the depth. Where is the plate? Justin, if this is your question, maybe help me a little bit here on this. On one side of the plate, using the coordinate system below. Is there a z-axis to this too? Like, and then I'm confused what this is. One side of the plate. Maybe this is the plate? I'm just confused why there's a y equals -4 here. And then this is a y equals -10. But the depth of the pool is equal to y. Yeah, wait, what? I think we're missing some information here. One side of the plate. Surface of the pool. But then they say this is -10 and this is 10. Let me see if I can get a better diagram for this, actually. Sorry. Yeah. This is a Calc 2 problem. Hi, Justin. What's up? Finding fluid force using integration. Most problems give more information about length and width and area, but this one does not. I agree. I'm just confused by, like, what the picture of this thing looks like, Justin. Right? Like, first of all, this doesn't line up, right, with the depth. And then... What is this the plate? But then why do I also have a triangle? And then why do I also have the pool doing things? It's just such an odd... That helps. Let's just go find it. Yo, what's up, Academy of Useless Ideas? Good to see you, brother. Academy of Useless Ideas. Nice. Yeah, I just want to know... Wait, I don't want, like, AI. Can I just get... Okay, here we go. Oh. Okay, maybe one of these diagrams is better. Descendant fonts. What's up? I don't. Oh, okay. Well, now this is all in Chinese. But I think at least we're getting like somewhat of a better diagram. Yeah, what we were originally given here, I don't really know what's going on. I don't remember any more emotes. It's all good. There's the surface. What's like what's the plate though? Oh, I like this image already. This is looking a little bit better already. Just because like things are shaded correctly. Right here, let's pull this. Also, it's from example 6, so I could just like reverse engineer this and find this. Unfortunately, I did like I took out my I got rid of my Chegg subscription because I wasn't really using it as much. This is the one time I kind of wish I had my Chegg subscription because this exact question is actually already done. It was basically just someone had like the solutions manual and was posting the solutions manual. It was the OG like ChatGPT. Yeah. But I feel like I can kind of understand this one now. Because at least like I see what was being shaded. Like before it was pretty difficult to understand what was even happening. Oh, interesting. But what's happening here? At a depth here, the pool is like right, and then the force on a side is equal to the density. Yeah, so here. This is where like physics works out, right? Okay, here we go. So pressure. Oh, there's some lag. Oh, I don't know why that is. We'll see. Pressure is equal to force over area, right? So then force is equal to pressure times area, right? But then the interesting thing is that the force can vary as we're integrating over the area, especially when you have situations such as like a tank, right? So in this case, when you have water and you're looking at what the pressure is at like, let's say this position here, this is going to equal to rho GH, where this is like the density. This is like the force of gravity. And then this is the height of the water column above you, right? So you end up having to integrate because the pressure here changes as you're integrating over the area. So this is going to end up becoming equal to an integral of PdA. Right? And okay, they do give you kind of some cool thing here, right? Yeah, okay. So we know that dA is going to be some integral of like dx dy basically. You say internet's also getting cut. Evening Femvox, what's going on? Descendant Font says I'm lost. What are you lost with, Descendant Fonts? What about this part so far? Okay. This is just claiming like what pressure is at like at any distance underneath a body of water. This is also why when you go down further and you're diving, you start to feel like your head's getting compressed. It's because there's more pressure from the force of the water above you. And that varies as a function of the height. So this is a basic physics thing, which we can then rearrange for this. Nice. And then because pressure is a function of the area, force ends up being the integral of the pressure dA. Okay. Which pressure doesn't care about how wide you are, right? Pressure only cares about the depth you are, the amount of water that's above you. This submission page is 10 times better. Nice. Love that. Yeah, see, there you are, Sibley. Yeah, awesome. Okay. So I think I'm getting this. I think I'm getting this. And here's the other cool thing. I think the pressure on all sides of this object are the same. I think that's a common thing. Let's see, pressure on all sides. I want to say it's the same. Yeah, pressure is exerted equally in all directions at any given point, meaning it acts on all sides of an object. And I think it's the same on all the sides, because pressure is a force over an area, and the force is the same. Yeah. Okay. Yeah. This is what they call like hydrostatic pressure. Very cool. Yeah. Okay. Okay. So when they say like calculate the fluid force on one side of the plate, that's the same force on all the sides of the plate. Okay. So let's do the way your question originally was asked, Justin, which I think was with it being at this was at -4, right? And then this was down at -10. And then this was up at 10. To begin with, the formula of pressure equals force over area. I'll learn physics someday, but deriving mathematically every formula like P equals F over A. Yeah. Yeah. I don't know exactly how to derive this, but this is just a physics concept. Why do things float to the top? That's because the buoyant force is more than the force of the liquid trying to keep it down. That's why. Yeah. Okay. All right. So let's come up with maybe some equations, I think, for this, because what I eventually see us doing is integrating PdA, where P is equal to rho GH, and I think whenever they give us pound per feet cubed, this rho G is what the density of water is, being 62.4. I think this is 62.4. And then this is going to be H, which is going to be in feet, right? And then if we do dA, that's going to be feet squared. So eventually we get feet cubed, and then this is pounds per feet cubed. Feet cubed cancel. And you're going to get a force, which is just pounds. Which I know, it looks like a weight. Weight is force. It's an annoying thing about physics. Interesting that this is given in a Calc 2 class, though, because I feel like this is more of a physics question. But what I think is going to happen here is we're going to integrate... Let me do this like step by step. We're going to integrate pressure dA, which is going to end up being integrating rho G, which is going to be 62.4 times the depth, okay? Because this is what defines the pressure. And then dA is going to end up equaling dx dy. And I think what I eventually probably want to do here is... What's up, Fabry? I think I can write out maybe dx, or instead of saying dx, I think we just say x dy. Yeah. Let's just do x dy. Right. Yeah. Well, it's going to be actually 2x dy is what it's going to be. So here, let me show you what this is. What if we do every integral combination and see what measures each integral? That might be a lot. Yeah. Okay. So I think instead of doing a double integral with dx, because that's just going to get me whatever like this distance is here. Like integrating dx will just tell me what this is if we go from -x to x. So here, this would end up being -x to x dx, which is just going to pull out a 2x. Thanks, Fanvox. I did have a good time at the wedding. Yeah, I'm glad to be back. Honestly, I hate traveling. When it knocks my schedule off. I feel like I had a really good rhythm running, like with streaming and everything, like my health, my diet, and everything. And then like I go on a vacation. It's not really a vacation because also like weddings are stressful, especially when it's your sister's wedding because your whole family's just like doing everything. This is depth. Okay, and then this is gonna be 2x, and then this is gonna be dy, and then the depth we're gonna go from is gonna be, we're gonna integrate from -4 to -10, right? So we're gonna go from being 4 underneath to being 10 underneath the surface of the pool. Wish I was good at math. Kyle, dude, if you just like lurk around, dude, you'll get pretty good at math, dude. I believe it. I believe in you, dude. Okay. Oh, and then the depth. Yeah, the depth is just y. The depth is y. Yeah, okay, cool. Okay. I see. Wait. So the last thing I need to do is then relate how the x changes with the y. Right? How much the width of this plate changes as we go further and further down. Spoiler, nobody's good at math. I agree. I'm not even that good at math, honestly. I'm perseverant. I don't fucking give up. Okay, this is a very cool thing to do. So if I want to relate x and y here, we know what the equation of this line is, right? This is just y is equal to x minus 10. So that's the relationship of what x is. So x is equal to y plus 10, right? So now this integral just becomes 2 times y plus 10. Yeah. -4, 10, 62.4. And then this is going to be y. And then there's going to be a 2. And then there's going to be y plus 10. Or yeah, y, x is equal to y plus 10, I think. Yeah, right? Right, because when x is equal to... x is equal to y plus 10. Yeah, because y is equal to x minus 10. Yeah. Cool. Nice. Okay. And then I think I just integrate this. I think it's all I do. Yeah? Get the -10 on the upper bound. Okay. Good question. Oh. I know why. Yeah, you're so correct there. Sorry. I always mess this up. Like, y points up. So we have to go from -10 to -4. Yeah. You're saying this is the way I have to do it, I think, right? Or did I have it right? No. Wait. Oh. Yeah, no, I think this is the way you have to do it. Oh, you missed writing a -10. Yeah. Oh, okay, wait. No, wait, so maybe I was right? Sorry. Which class syllabus? I think this is yeah, sorry, no. It goes from -10 to -4, right? It goes from the smaller y to the bigger y, right? Yeah, because you're measuring the volume of a... Well, I don't know if it's a cylinder. We're measuring the area of this plate. Yeah, exactly. We'll just figure it out after sign issue at the end. Yeah, whatever. Okay, cool. So that's 124.8, and then that's gonna be integral from -10 to 4. Sorry, I forgot the dy. Don't murder me. I'm sorry, I forgot the dy. And then that's gonna be 2y plus 20, or sorry, 2y squared plus 20y. Yeah. Okay. So then that's 2/3 y cubed plus 10y. Riemann integration. Okay, that's cool. Yeah, this is apparently like Calc 2, which I think is second semester. So, yeah. Okay, 124.8. And then we got to do that from -10 to -4. Oh, and you know what I fucked up here? Sorry, depth needs to be not... Depth here needs to be -y. right? Because the depth is a positive number. If we're looking at like force on something, I see. So sorry, this is a negative. So, oh, that fucks things up. Okay, sorry. So whatever, just pull the minus sign out. There you go. Okay, now we're good. Yes, and thank you. 10y squared. Sorry. Yeah, this goes up by power, becomes y squared, divided by 2, 20 over 2 is 10. It is a cubic volume. Yeah. Okay. So, I don't know. I kind of need a calculator for this one, I feel like. Just because it's kind of some icky numbers I don't really want to deal with. So let's do, sorry, why is my alpha locked? Excuse me? The hell? What the fuck? Alright, whatever. Let me try fixing this. Okay, there we go. Okay. So 2/3 times here. Let me just do it with variables. I'm gonna say that -4 stores to x. It's just a quick way to just so you're not typing in the same number all the time. I'm gonna do 2/3 x to the third plus 10 x squared, right? And then I'm going to do that minus, well, then here's what we do. So then we store, we store -10 as x. And then we do the same thing. Oh, wow, $120 and a 4 megabyte. Yeah, it's crazy, right? Wait, why does it keep... Oh, you know what I think it's doing? Okay, there we go. Okay. And then we do this. Okay. And then we do this one minus the other one, which will give me a negative answer. Right. But then I'm multiplying it by negative as well. -124.8. Nice. Okay, cool. So then that gets me 2,700 pounds? 27,000 pounds? That seems pretty high, honestly. It's whatever. Who cares about the answer? I kind of care. I like getting the right answer. Austin, if you're still... Justin, sorry, if you're still watching, can you let me know if that's the right answer that you got for it? I could also throw this in the ChatGPT, see what it gets. Yeah. Okay, cool. All right. We're gonna assume it's right, so we're gonna say 27,000 pounds. And you're done. Nice. Fun question.
Well done! Well done!
Cool. That was a cool question. And now I'm gonna mark it off on the admin console. Mark that one done. And it should update the queue. I like also that there's a timestamp so I can see at what point we had a question asked. Yeah, you're welcome, Justin. Hope that helped out. Let me know if I'm right. I 27,000 pounds seems like a lot, but I think at the process I trust is correct. Okay. I think we have another physics question coming up. That was kind of physicsy. Let's see what we got here. So, let me get rid of the calculator. Okay, how do I get rid of the calculator? I think I do that. Okay, there we go. Whatever. Okay. Two long parallel wires are distanced 2a apart as shown above. Let me see. distance A from wire X, where there is a current I in wire X and no current in I in wire Y. Okay, so here, I is... Well, here, we'll just say that this has current I. I equals I guess. This is I equals 0. The magnetic field at point P is equal to B naught. Okay, so B is equal to B naught. Okay, great. When there are equal currents in the same direction in both wires, the magnitude of the magnetic field at P is what? Oh, interesting. Okay. So, I believe this comes down to this equation, right? So, B dot dl is equal to mu naught I enclosed. Correct me if I'm wrong. I think that's what that is, right? Is it mu naught over I? No, I think it's mu naught I. A current here that's running down a wire, it ends up creating a magnetic field that kind of looks like this. It curls around it. And if you integrate B dot dl around that, you get mu naught times the current that's enclosed in there. Which, B dot dl, if we're going around in a circle, dl is the same thing as 2 pi r, where r is the distance away from the wire. So this is the common like simplification we get for just lines of current and figuring out the magnetic field, is that B times 2 pi r is equal to mu naught I. So then B is equal to mu naught I over 2 pi r. Wait, someone was asking in my TikTok. What'd you ask here? I'm a layman. What math is used? What math is used for programming? Math is used for everything. People ask me like, what do you use math for? I use math. You do math for anything. I don't know. Even going to like buy groceries, I have to do math and figure out like, do I have enough money to afford this? Okay. So here's a cool thing. So whenever, and here's the other great thing about magnetic fields is I think they're additive, right? So the total magnetic field at a point here is equal to the magnetic field due to this wire plus the magnetic field due to this wire. Isn't the magnetic field decreasing with r squared distance? It doesn't actually if the wires are considered long and infinite though, Lelephant. Yeah. Has to do with, yeah, here, magnetic. You're right that well, for a line of charge it ends up being like ln of r or something. Magnetic field from current of wire. Yeah. Yeah, this is it. It's mu naught I over 2 pi r. Hyperphysics, I guess. I like hyperphysics. Yeah, this is a great website. I love these guys. Hyperphysics are awesome. Where's the one for, let me see. I believe this is called, whose law is this? Whose law is this? It's Ampere's law. Yes, this is it. So Ampere's law says the space around an electric current is proportional to the electric current which serves its source. Okay. This is really the thing that comes up with this. And yeah. Yeah, so it's not 1 over r squared. What you may be thinking about is the electric is the force due to an electric field. Sorry, the force due to a point charge, or the electric field due to a point charge, which is 1 over r squared. Magnetic fields decrease as 1 over r for like lines of current. Is how that works. So, right. So when the second wire Y here has no current, it doesn't contribute any magnetic field. So we only have to look at this. And so from that, we know that B naught, because that's the magnetic field felt at point P. Asking questions is great. Just keep doing it. So this is going to be mu naught I over 2 pi A, okay? That's the magnetic field due to just this wire, okay. And then there's an equal current in the same direction in both wires, okay. So that's a cool thing here. So let's say, for instance, that the current's running up in this direction, okay? That's going to end up equaling, is going to create a magnetic field that curls around, such that magnetic field is coming out of the page here, which we write as like kind of a target type thing here. And it's going to then curl and put magnetic field into the page over here. Actually, let's use the same colors for these, sorry. Because then I'll show you what happens when they switch. Yeah. So this is the way we kind of write that. This is the magnetic field profile due to this. Now, if this also has current that, let's say, is running in this direction, it'll do the same thing, where to the left of the wire, that's going to force magnetic field to come out of the page, and then to the right of the wire, that's going to force magnetic field to go into the page. And that continues even way out here. It's going to become lower and lower. So as you get like further and further away, the magnetic field like drops off by 1 over r. And that comes from this. B is equal to mu naught I over 2 pi r. So then when we have the magnetic field from the other one, so let's say like B1, that's going to be equal to mu naught I over 2 pi, but the distance that point P is from this wire is now 2a plus a, so that's 3a. So that's times 3a, which is the same thing as 1/3 mu naught I over 2 pi a. And let's remember that mu naught over 2 pi a was just equal to B naught. So now your total magnetic field, so we can say like B total, which is going to equal to B0 plus B1, is equal to B0 plus 1/3 B0. So that should just be 4/3 B0. I think. Which, yeah, I think that's correct answer choice D here. Yeah. I believe that's right. You can always double check. Let me just throw this at chat. Where's ChatGPT? There you are. Go solve me something, ChatGPT. And here, don't use the expensive models. Let's just use 4.0. Let's just see if that comes up with the right thing. Okay, and then let's look real quickly at like what would happen if they were oppositely directed currents. This is really cool. So in the case of this second wire having an opposite direction of current, so let's say, for instance, this now is the direction of current for the second wire. You use what's called, again, it's the right-hand rule, which is like this thing. This is kind of how we look at it. Yeah, this is how we look at it. So you curve your hand around it. Your thumb points in the direction of the current, and then your hand, the rest of your 4 fingers curve around and show you like which way the magnetic field is coming. So in this diagram, for instance, on top of the wire, the magnetic field is coming out of the page. And then below the wire, the magnetic field is going into the page. So in this case, if magnetic field is now pointing down, thumb's pointing down, right? That means magnetic field goes into the page on this side. And it goes out of the page on this side. And so as you get further and further away from this wire, now the magnetic field here cancels out. Or not completely cancels out, but starts fighting the magnetic field that's created from the orange wire, from the X wire. So in that case, instead of them adding to each other, they would subtract. So in the opposite case, you wouldn't get B1 plus 1/3 B naught. You get B1 minus 1/3 B naught. And then this would equal to 2/3 B naught. So, yeah, that would be your final amount. Cool. Let's see. Let's see if that's what they got here. They got, the answer was, oh, wow, this is a lot of, wait, what? Dude, yo. Okay, it got the right answer eventually. 4/3, yeah. Sebas says, I rewrote mine to take a picture because I have writing all over the question in the paper. That's okay. Appreciate you doing that. But okay, great. Awesome. Does that make sense to you, Sib? Yay, great. Thank you for the really awesome, thorough explanation. Thank you, Sib. Thank you for the question. Sick. Nabs is saying, how do I submit homework? There's a website right down there. You see it, Nabs? Submit, actualdiscord.com/submit. If you just go to that website, it'll let you do it. You can just submit a screenshot. I'll go over it. Com. I think if you just go to actualdiscord.com, I think I pointed it correctly. I've had to like figure out a lot of SSL and whatever. Oh, okay, cool. Yeah, it does. Yeah, if you just go to www.actualdiscord.com, it'll also take you straight to this website where you can just drag and drop like a screenshot in. Nice. Okay, cool. So the great thing is, now I'm going to mark that one as done from Sibley. Mark is done. And now we're on to Rockstorm. Let's see. Meow1 Dogfish says, if you fix the wire on the right, but the wire on the left is free to move, which direction does the wire on the left move when the currents are in the same... Yeah, this is cool. So that has to do with a more advanced concept, which is F equals ILB. Which says that the force on a current of wire is equal to the cross product of the current in that wire times the crossed with the magnetic field it's experiencing. So I can definitely help with chemistry. Yeah, I do a ton of chemistry, Max. Just submit a screenshot. I'll do it. There's only 2 people in the queue so far. I'm going to do Rockstorm, and then I'm going to do Sebas. So submit down there, website. And yeah, give me a screenshot. I'll do it. So in this case, what's up? Yo, what's up, Equity?
Good job.
What is it? F is equal to I, L cross B. Where L is like the direction of the current as well. So if this is going up, and then the magnetic field due to this one is pointing, what's that, out of the page, right? Right, so if they're pointing in the same direction, then they attract towards each other, right? Okay, that's cool. So same current means that they snap together. Opposite currents, they move apart. Do I have that right? Let's see. Current parallel currents and force whatever. Yeah, it's something like this. Oh, I have it right? Okay, cool. Yeah, this is like the explanation. Yeah. Right, okay. Yeah, it's F equals ILB. So if they're going the same direction, they snap together. If they go in opposite directions, they push each other apart. So this is really cool. If you have any sort of current system, which is like switching back and forth, you end up having these things just like clap and slap each other. F equals QVB, yeah. Okay, let me get Rockstorms going up. Oh, Rockstorm, this always hurts me, dude. The mass on top of the mass, dude. The mass on top of the mass. Yeah, this one's always scary. I mess these up. I'm going to be a full disclaimer. I mess these up too all the time. But the key trick here is to always consider each individual mass by itself. Clap and slap each other. Ayo. Pause. Okay. So it says, okay. A slab of mass 1 rests on a frictionless floor, and a block of mass 2 rests on top of the slab. Between the slabs, between the block... Wait, what? Sorry. Okay, so a slab is apparently just a bigger block. I feel like I have to write, like, this is the slab. I need a better color for this, too. Slab block. Okay. But there is a coefficient of friction, 0.6, and the coefficient of kinetic friction is 0.4. A horizontal force of F of magnitude 100 newtons begins to pull directly on the top block. In unit vector notation, what are the resulting accelerations of the block and the slab? Wow. Okay. This is cool. All right. Whenever these types of questions come up, Rockstorm, Nabs, I see your question too. Good job. Good job figuring out how to submitting it. Yeah. And you got an exam tomorrow? Cool. Well,
My man.
we'll make sure to help you out. Okay, so here, if we have block, I'm going to draw block first, and then I'm going to draw slab. And we're going to consider only the forces acting on each thing. So on the block is going to have a force of gravity pulling down, right? Wait, well, let me get a better color. There you go. Force of gravity pulling down, and that's going to be equal to m2g, right? And then vice versa, it's going to have a normal force, which a lot of times we call this... So if we call this thing number 1 and this number 2, this is also the same thing as F2 on 1. Because the normal force that this block feels is the force from block 2 pushing up on block 1. And that's going to be important here. And then we have a pulling force, which is equal to 100 newtons. And then friction always opposes the motion that something wants to go. So in this case, we're going to have the force of friction. Okay? That's going to be it's going to be fighting this pulling force on the top block. Now looking at the slab. Okay, the slab also has a force of gravity, which is going to be equal to m1g. And then here's some of the key things here. It's also going to feel a normal force upwards, which is going to be from the ground. We say like force of like ground on block 2. But then this is what's called a force pair, Rockstorm. Because block 1 feels slab 2 exerting a force up on it, slab 2 is going to feel that same force pushing down on it from block 1. So this right here is F1 on 2. And this is called a force pair. So maybe you learned one of Newton's laws, right? It says for every force is an equal and opposite force, right? Every reaction, there's an equal and opposite reaction or something. So that's why these are the same. And then the same thing happens with the friction. So if friction is trying to pull block 1 to the right, but that's on top of it, right? Let's say like this is on top of it right here, and friction is trying to pull it to the right. Then on slab 2, friction is trying to pull that thing to the left. So this ends up having the same force of friction, but it points in the opposite direction. A lot of times when we deal with force of friction, we don't care about what the force of friction is doing to the ground. We only care about what the ground is doing with the force of friction to whatever our object is that we're pulling. But this is a special case where if you have two objects on top of each other, you now have two places that the friction shows up. It shows up on the primary thing that's trying to move, and then it shows up in the opposite direction of the thing that it's on top of that is providing like the friction. Does that make sense there? Rockstorm? This is a very tricky thing that sometimes messes people up. Okay. Let's do some math. So this is always the hardest part in physics, is just setting this up. Once this is up, everything is just math. So if we do sum of forces in the y direction, let's say for this one, you have F2 on 1 minus m2g needs to be equal to 0, right? Sum of the forces has to equal the mass times acceleration. I hope this thing is not moving in the y direction, so the acceleration is 0. And then sum of forces in the x direction is equal to the pulling force. I'm going to call this positive and this negative. So I'm going to just say that's 100 newtons minus the force of friction. Okay. And then in this case, what's a dead 5G is like, what's wrong? What's wrong? Is it scary? We're just doing some physics. Well, this is one of the many things we're doing dead. So I also, well, we did some physics here, but we also did like some calculus here. Or, I mean, I've done everything from what here. I think we were factoring like quadratic here. This was like factoring quadratic. We do all sorts of math, Dread. It's just the current question is a little bit advanced. Yeah, no, you can, if you have a question about honors geometry, feel free to like submit it and I'll go through it. This is just one of the more advanced questions we got to do. Okay, let's see. Sum of forces in this direction, you're going to have wait, why did we say this is FG2? Oh, force of the ground. Yeah, okay, cool, whatever. So, force of ground on slab 2, and then that's going to be minus F12, which is the same as F21, and then minus M1G, and that also has to be equal to 0. And then the sum of the forces in the x direction, well, that just has to equal the force of friction. Yeah, I can do some biology. Biology isn't too bad.
Nice.
Happy to help out with biology. Is it okay for me to just YouTube videos for Physics 1? Yeah. I mean, if that's the way you learn, yeah, do it. I mean, you should get used to reading a textbook at some point because, I don't know, like textbooks tend to be the preferred way for older professors, specifically like college professors, to teach. They're not going to make you fun YouTube videos like I do. So, you have to kind of get used to that. Polyatomic bonding. Yeah. Like multiple things bonding. Yeah. Yes, if you understand better with videos, great. I'm just saying it might be helpful to learn along the way how to try to learn from textbooks, because it's going to be a while before the old dinosaurs decide to stop doing textbooks. Yeah, you're welcome, dude. Yeah, if you have a question, again, there's a queue down there. Just submit a screenshot and I'll go through it. All right. The resulting accelerations of the block and the slab. So the accelerations in the y direction should all be 0, hopefully. Otherwise, things are flying off, and we don't want that happening. So here's the issue with a friction question, though, Rock, is that I need to make sure that the maximum force of friction provided could not stop this thing from moving. And in order to do that, we need to come here and then realize that the force of friction is equal to the normal force, which in that case is F21, and then times mu s. This is the maximum force of friction that could be provided. And from that, so F21 is going to be equal to M2G. And what was M2? Did they give us? M2 is 10 kilograms. Okay, so 10 times 9.8 times mu s. I already know Ragucci here because this is 98 newtons and there's no way mu s is greater than 1. So it is going to move because the maximum force of friction that can be provided is what is it? It's 98 times the coefficient of static friction. So here, let me just do it for you. Sorry. I get ahead of myself sometimes. 10 times 9.8 times 0.6. And if we pull that up on a calculator, let's pull it up. 98 times 0.6 is 58.8. Okay. So 58.8 newtons. But the force you're pulling with is bigger than 58.8 newtons, so it's definitely going to move. So now instead of having static friction, you have kinetic friction. So instead of this 0.6, we need to use a 0.4. So we end up getting this times 0.4, and that's going to give me 39.2 newtons. So that's the force of friction. Okay. So now, if I want to figure out the acceleration of the block, right? Well, I just need to figure out what the sum of the forces in the x direction is for the block, because this is equal to the mass times acceleration for the block. And so 100 minus 39.2 is equal to 10 times A. So that's going to be 60, what was that? 60.8 is equal to 10A. So then A is equal to 6.8 meters per second squared.
Good job.
Okay, so that's the acceleration of this thing. So then if we want the acceleration of this, well, on the slab, the only thing that is moving in the x direction is friction. And that force of friction from the slab on the block is the same from the block on the slab. And so it's the same 39.2. But now this is equal to 40A, right? Because this is equal to the mass of the slab. And then 39.2 over 40 is basically 1 meter per second squared. So you can see that the top block will accelerate faster to the left. And as it does so, it'll start to pull the slab a little bit, but not as quickly. Okay. Does that help out, Rockstorm? Is that good? Make sense? I hope. Nice. Okay. Sweet. All right. Let's clear that question.
Well done.
Next up is Sebas.
Well done.
Okay. How do you find the circumcenter of a triangle given 3p? Femvox loves physics. We like physics, don't we, Femvox? Yeah. Jeff doesn't like physics. But hey, Jeff, someone's asking a question about how do you find the circumcenter of a triangle given 3 points? Oh, nice, Equity. Oh, okay. That's a cool question. Here, I'm gonna post yours in as well. I wonder if I can do this actually. I want to see if this works. So for those that don't know, this is the new way that Equity, you probably just, this is the new way I'm doing the questions. So if you go to this website and then I think if you just hit like, can I just paste it in here? I wonder if I can. No? Can I do this? Oh, there you go. Look at that. Yeah, you can just drag it in here. I can hit Equity. And it should upload it. Oh, it doesn't like this? Man. How do I open this? Like maybe I gotta open it this way. Let me see. Maybe this works. Fluid mechanics and heat exchange. I can definitely try. If you want to submit a question, I can try to do it. I don't know why this doesn't. Okay, fine. Fuck it. It should upload. Oh, there you go. Okay, now it's gonna work. Yeah. It'll do it eventually. Okay, let me do this one real quick from this is from Sebas. Your teacher explained it badly and the whole class is confused. Uh-oh. Okay. Equity says, why no more help screenshots channel? Because I get a lot of questions now, and I can't do everything just from Discord. It's a way to just, like, organize it well. Yes, I saw the one you submitted. I'm on. You are number 6. Yeah. There's a whole, there's a queue. I'll show you where the queue is. I think if you do... One second, let me find it real quick. Yeah. Yeah, this is the queue. So I see yours right there. It's ray optics. Ooh, okay. All right, let's see this. A 62 kilogram person on skis is going downhill, sloped at 12 degrees. The coefficient of kinetic friction is 0.15. How fast is the skier going 5 seconds after starting at rest? Okay, this is a great question. I like this one. All right, let's draw a force diagram. I'm going to pretend this is 12 degrees. It's not, though. But, yeah, let's call this theta. Okay. So then if you have this, you're going to have force of gravity pulling down. That's going to be equal to mg. You're going to have the normal force pointing this direction. Yeah, it looks like 30 degrees. I know. Yeah, it's definitely not 12. Okay. And then that means you have two things here, right? So you have this, which is FGX. And you have this, which is FGY. And then you have friction. So if this thing is trying to go downhill, friction is going to oppose that motion. Yeah, this is definitely physics. And so friction is going to point in this direction, Sebas, right? So it's actually cool. There are a couple ways to do this question. Depends if you want. Are you allowed to use conservation of energy, or are you just supposed to use F equals ma and then kinematics? Because there's a couple ways you can do it. Yeah, kinetic friction only depends on the mass. Yeah, correct. Okay, F equals ma and kinematics. Okay, cool. Okay, my next question to you. Do you understand that this is mg sine theta? And do you understand that this is mg cosine theta? Or do you know like where that comes from? Highest level of physics, probably quantum. I could do some quantum. I prefer like undergraduate mechanics, E&M and stuff. Yeah, exactly. Okay, cool. All right, so let's figure out what the force of friction is, right? Because sum of forces in the y direction, where what I'm doing here, for those that want to like kind of see how this works, I'm going to take this whole thing here, and I'm going to rotate it. So what we're going to do here is we're going to do that. That's kind of what we do. So now this way is x, and this way is y. I know it's not perfectly straight. Don't kill me. Yeah. Is this what you mean, Sebastian, by shouldn't it be the perpendicular direction? Does this make sense? We're going to call this like the x direction. We're going to call this the y direction now. As opposed to what we had here. You're a star, bro? Wow, thank you, dude. I identify as many things. A star's pretty dope. Yeah, it's rotated a little bit differently. Yeah, so here's what happens is, yeah, this rotates this way. I agree. Sorry, I'm like trying to like make this look correct. Yeah, there you go. It's kind of rotated, notated. Yeah. You ain't a star, but a superstar. Superstar. Okay, let's just do this. Sorry. Okay, so sum of forces in the x direction. You only have one. You have two forces in the x direction, right? You have the force of friction pulling you to the left. So I'm going to say minus F fric. And then you have plus the force of gravity pulling you in the x direction, which is mg sine theta. Okay? Theta, the y component of gravity pulling you down. So that's minus mg cosine theta. And then sum of forces is always equal to like mass times acceleration. In the y direction, acceleration should be 0. Because this block should not be moving up and down off the ramp. So this is 0. In the x direction, however, this will have some acceleration. So we're going to say this is going to be equal to ma. And this is the acceleration I care about. All right, so I want to solve... And again, whenever I see any physics question, I try to think backwards from what we're trying to get to. I'm trying to get how fast is the skier going 5 seconds afterwards. Think about in kinematics what equation relates how fast something is going after a certain amount of time. It's this one. V is equal to V naught plus AT. We know V naught is 0 because this thing starts at rest, I hope, right? Starting at rest. So if I can figure out, and I know the time here is equal to 5 seconds, right? Exactly, Amon. It's the first equation. If I can figure out the acceleration, I can figure out the velocity after 5 seconds. So I'm going to figure out that acceleration. And I'm going to do that using this equation. Okay. So, force of friction. So you have minus mu k Fn plus mg sine theta is equal to ma. And then to get Fn, we use our y equation here, which tells us that Fn is equal to mg cosine theta. Can you re-explain force of y? Why not Fy just equals cosine theta? Because there's also a normal force. So this block here has the normal force pushing it up, and then it has Fgy, so the y component of gravity, which is trying to pull it like into the plane, into like the inclined plane. And the sum of those forces have to be 0, because as this thing like falls down the inclined plane, I need it to stay stuck to it, which means I need this force and this force to cancel each other out. Okay. Yeah, you're good, dude. So, so you get minus mu k mg cosine theta plus mg sine theta is equal to ma. Something really cool here. Notice how there's an a everywhere. Sorry, there's an m everywhere. I can get rid of this. I can get rid of this. I can get rid of this. So acceleration actually doesn't even depend on the mass here. That's actually a really cool point of this. Now we just plug in numbers. 0.15. And then coefficient of friction was... Yeah. I'm very good at mechanics. I'm pretty beast at mechanics, dude. Okay, so this is 0.15. And then we're going to say 9.8. And then, what was it? Cosine of 12 degrees. Plus 9.8 sine of 12 degrees is equal to the acceleration. Cool. So where's my calculator? So, what is that? Negative 0.15 times 9.8 cosine of 12. Plus 9.8 sine of 12. Yeah, any sort of practice is great. Griffiths is good for mechanics if you want to get better at mechanics, especially if you want to take like upper division mechanics. Okay, so acceleration is 0.6. Perfect. Okay, so now we plug that in here, right? We get 0.6 times 5, and so you should get 3 meters per second. Was that the correct answer that they had for it? Yes, nice, good job. Ash says...
Well done.
Wait. Your teacher said 5.7? Oh. Well, I don't know if that makes sense. Wait, what? 5.7? We did not get that answer. Yeah, wait. Yeah, I think they got it wrong. I think they got it wrong, too. 5.7 is fast. Yeah, especially because this is only a 12-degree incline. That's not very steep. Yeah. Ask AI. Yeah, we can go do that real quick. Yeah, let's do it while we wait. Sorry, let me just throw this in. Ash says, why not use the Casio FX? So, I mean, the Casio FX is a great calculator. Don't get me wrong. The issue is that, at least in the United States, they tend to do everything on a TI. So that's why I use the TI calculator. They'll usually... Like a TI-84 is pretty standard. Or, like, I physically have one if you want to see. I have an actual TI-84 here. That's just why I do it. No, Griffiths has a mechanics class, a mechanics question, too. I'm on. Totally does. Or maybe I'm thinking the E&M course he has. Yeah, you can do it if you want. Yeah, it's totally cool. All right, let's see. Yeah, they get 3 meters per second. Look at that. Nice. Okay, cool. We did it. Oh, yours is mint colored? I have a gold one. It's just, yeah, it's in my book bag somewhere else. Oh, you can't find it? Let me think. I'm pretty sure it was Griffith. Does Griffiths not have a mechanics course? One sec. Oh, he has a quantum mechanics. Which one am I thinking about? Sorry, that's the mechanics. I'm thinking of E&M, I think. You're right. I'm messing up. Maybe the Feynman lectures. Wait, Feynman lectures? Yeah. This has some really good mechanics in it if you want. Yeah. The Feynman lectures. This guy's pretty... And Feynman was a fucking G, dude. He was the GOAT, dude. Yeah. Yeah. Go for that. You're very welcome, Spaz. Okay, Mark is done. Next one is Nabs. Got a lot of fun questions coming up. Okay. Interesting, Nabs. Very cool question. I've taught at the undergrad level. Here, let me delete all these pages. Actually, no, I'm not gonna delete them. Oh yeah, Taylor. Taylor, that's the other guy. Yeah, sorry, I'm trying to think who it was. Yeah, Taylor. Taylor's great. Yeah, I've taught physics at UCLA, so I've taught at college level. But I do everything at middle school. I have to tutor a student in like Algebra 2 in an hour. So that's pretty middle school level. Yeah, math. Jeff is so happy when there's math. Trig half angles. Yeah, those can be pretty rough. Okay. What does injective mean? Sorry, what does injective mean? Jeff says math is the only true subject. Oh, injective means 1-to-1. F of x equals f of y implies x equals y. Okay, well, let's go figure that out. It can be 8th grade. It depends how advanced your school is. You're right, it is more advanced usually. Okay, so wait. Does f of x equal f of y if x equals y? Okay, that's... Injective means 1-to-1. Okay, so f of x equals f of y implies x equals y. So does 2x plus sine x equal 2y plus sine y? I think you can show here that f of x is always increasing. Okay. I kind of like that. Yeah, so here's what Jeff is saying. So, injective means 1-to-1. Which, for instance, if you have a graph of something that's 1-to-1, it means it always has to be increasing or it always has to be decreasing. If something like decreases and then increases, this is no longer 1-to-1. Because you can have two different values of x that get you to the same value of y. Or, I mean, if even if you had like something like this. You see how like this and this, two different values of x, same value of y? So, if you can show that a function is always going up, then for every x, there's a unique y. Horizontal line test works too. Okay. So, in order to show... so, f prime of x, if you take the derivative of this is equal to 2. Derivative of sine is cosine, so plus cosine of x. And this will oscillate between -1 to +1. So f prime of x will 1, which is 1. This is always positive.
Yeah.
So if the derivative is always positive, Nabs, that means it's always increasing, which means it's 1-to-1. It's definitely not linear. I agree with that. It's not linear anymore. But what you have here is, this is actually really cool. If you look at this as a function, you have f of x is equal to 2x, which looks like this, right? This is f of x is equal to 2x. And then plus sine of x means that you have this thing on top of it. So if you do it like on top of it, it ends up being like this kind of. It's like a squiggly on top of a line, but it's always going up. Yeah. It's transcendental, in fact. Oh, thanks for that fact there, Jeff. That's cool. It's transcendental. Okay, show that the point P 2 pi comma pi lies on the graph of f inverse of y. F inverse. Okay. So if f of x is equal to 2x plus sine x, can I do the typical thing where I just say, oh, this is y is equal to 2x plus sine x, and then say x is equal to 2y plus sine y? I don't think that's going to work, right? Because then how do I get this to be y equals x? Well, okay. F inverse of 2 pi equals pi is the same thing as f of pi is equal to 2 pi, right? Yeah, this is true, right? So, for instance, yeah, exactly. So that's what this is. This is exactly, right? This is x, this is y, but if it's the inverse function, right? Okay, awesome. Right. Fembox has it. He says if a comma b is on the graph of f, then b comma a is on the graph of f inverse of y. F inverse. Okay, I like that. That's great. Yeah, don't try to invert it.
Surprise, motherfucker.
Don't do it. Okay, so from this, right? From this, what we have here, right? Let's just see if f of pi equals 2 pi. I think it does, right? Because 2 times pi plus the sine of pi is 0. That's just equal to 2 pi. Nice. Okay, so that's great. Love that. Determine the equation for the tangent of the graph f prime of p at p. Okay, so remind me, I think this is how it is, right? So f prime, it's like f prime inverse. How does this work? Is it this? Or no, fuck it. I'm gonna do this. Okay. Okay. I think it's what we say. We say, like, let g of x equal f inverse of x. Then g prime of x is equal to 1 over... I think it's f of g inverse of x. Is that how it works? The derivative of an inverse derivative? Oh, this is it. This is it. I think I had it right. Well, close. I had it close. Actually, I was actually nowhere close. Sorry. Yeah. This is equal to the derivative of the function evaluated at f inverse of y. Okay, I think I get this. So, yeah, because in order to get the equation of a line tangent, right? So, tangent to f inverse is going to be y is equal to, like, f inverse prime times x plus b. This is like slope intercept. So I need to get this. And at point P, which is 2 pi comma pi. Oh, okay. Oh, okay. And from this, guys, we know that f inverse of 2 pi is equal to pi, so that f of pi is equal to 2 pi. Okay, this is going to make things so much nicer. Okay, so I need to take... I need the derivative of f. From here, f prime is equal to 2 plus cosine of x. Okay, but then I need to evaluate that at f inverse... f inverse of 2 pi, which is pi. Oh, okay. So f prime of f inverse of 2 pi is the same thing as f prime of pi, and this is f prime, so that becomes 2 minus cosine of x. So 2 minus 1, which is equal to 1. Okay, so now you have y is equal to 1 times x plus b, and then to figure out this point, I think we just plug this in, right? So now you just say, like, pi is equal to 2 pi plus b, so b equals minus pi. Deji's had my head out. Thanks for coming by, dude. So nice. So y is equal to x minus pi. I think that's right. Did I get that right, Fembox? I think that's for part C there. You're awesome. Thanks, man, dude. You're awesome. Why capital pi, though? Is that a capital pi? Oh, you didn't work out? It's okay. Here, let me just throw it at chat. Oh, sorry. Where's my chat GPT? Just go. Let's see if I got it right. I'm pretty sure it does. Good. Yep. Here we go. F equals x minus pi. That's what I had. Nice. Good job, guys.
Well done! Well done!
Sick. GG's. Okay. Do you want to do some integrals? And then Max, I see yours with the chemistry. So here, let me mark Nabs is done. Anything that's not physics. Jeff just hates physics. Or chemistry or biology. Okay. So usually I wouldn't do 2 questions in a row from a student, but Nabs has been waiting since 42 minutes ago. So I will do this one. And then Max, I got yours. And also because Jeff really just wants me to do math. Actually, I think I'm going to do one of these, because I think doing both of these would take me a lot of time, and I do have to run in like 30 minutes. Okay. Compute the following convergent generalized integrals. Oh, I mean, this isn't bad, right? Can I just separate this? And this is just the integral from 0 to infinity of 3 e to the negative x dx minus 2 times the integral of e to the negative 2x dx. Yeah, these are really easy. Yeah. Yeah, okay, cool. So this is just going to be 3 times negative 1, and that's e to the negative x from 0 to infinity. And then this is going to be plus 2 over 2 e to the negative 2x from 0 to infinity. Let me know if you want me to explain how I did this. This is called U substitution, and I think everyone should... U substitution with integrals is the reverse of the chain rule. So with the chain rule, this would usually be negative 1 times e to the negative x. So this becomes e to the negative x divided by negative 1. And then with this one, nice. Instead of being negative 2 times e to the negative 2x, it becomes 1 over negative 2 times e to the negative 2x. Yeah. Yeah, it's just e to the u du, I think, right? Thanks for the follow, Nabby Babby. So, please explain further. Okay, I'll do it. I'll do it. I will do it. I will do it. I will do it. I got you, dude. Okay. This to me, so all I did here is, because you have 2 things that are just adding and subtracting, you can break them up into 2 separate integrals that, in this case, are subtracting from each other. So what I'm going to do here is I'm going to do what's called u substitution, because I know that the integral of e to the u du is just equal to e to the u. This is something we know, right? So I want to try to make this look like this. And so what I'm going to say is that u is equal to negative x. So then du is equal to negative dx. Okay? And so if I rearrange this, instead of saying du equals negative dx, that's the same thing as saying dx is equal to negative du. It is one of the most... What's up, Dr. L? Good to see you, bro. Yeah, it's a great function, e to the x. A lot of things in life follow e to the x. Or e to the negative x. Okay, so watch what happens now. So now I have 3, 0 to infinity, and now this is e to the negative x, but negative x is u, so this is e to the u, and then dx is now negative du. And that's why I say this is now the integral of negative 3, 0 to infinity, e to the u du. Integral of e to the u is just e to the u. And so this is negative 3 e to the u. And then you have to remember what u was. U was negative x, so you replace that. So then that's e to the negative x from 0 to infinity. And that's what I got here. See how I still got the negative 3 e to the negative x from 0 to infinity? The same thing happens here. You say u is equal to negative 2x. Du is equal to negative 2 dx. So dx is equal to negative 1 over 2 du. All you're doing is you're taking this and you're dividing it underneath. But the integral sign does look like an S. Yeah, I know. It might, yeah. It kind of looks like an e to the x almost. So now 1/2 of this negative 2 are going to like come outside. And that's where this comes from. And that's why the minus became a plus. So now you get 2 over 2 integral of e to the u du, which is just e to the u. And so that just becomes 1. So basically, and then u in this case was negative 2x, so it's e to the negative 2x evaluated from 0 to infinity, which is the same thing I had here. So I just think it's very valuable to, if you want to speed up your time on doing integrals, to see easy u substitution stuff as just the reverse of like integrating. So here's another example. I'll just show real quick. Let's say, for instance, you want to integrate sine of 4x, okay?
Nice.
I know the integral of sine is negative cosine of 4x, but then you have to like do like an opposite chain rule, which the opposite of 4 times x is dividing by 4. So this becomes times 1/4. And this is the integral of this. In the same way, right? If you did ddx of sine of 4x, that would be equal to 4 times cosine of 4x. But if you want to do the integration, it's like the opposite of the, it's the opposite chain rule, kind of. It's like the inverse chain rule. New math lord just dropped, right? Yeah. If it's anything simple, with u sub, that's how it works. For instance, if it's this does not work. You can't say this is 1 over 2x e to the x squared. That doesn't work, okay? If it's just simple multiplying or dividing, then you can. Yeah. Okay. So then when you evaluate this, we have negative 3. And so we have e to the negative infinity minus e to the 0. That's what this turns out to be, right? And then we have plus 1 times e to the negative 2 times infinity, which is just still negative infinity. Like, infinity times anything is infinity. And then this is minus e to the 0. So let's see what we get. E to the negative infinity is 0. Right? Because e to the negative infinity is the same thing as 1 over e to the infinity, which is the same thing as 1 over infinity. 1 over infinity is definitively 0. So then this is negative 3 times negative 1 plus 0 again minus 1. So it's just equal to 2. What about infinity times 0? Infinity times 0 depends how quick the 0 is happening. Yeah. What's up? What's up, Jaden? Good to see you, brother. Okay. So that's how you do that, right? I'll leave this other one as an exercise for you to do. This one's also very similar. Just trolling, continue. In this one, I'll give you a hint. U is equal to -1 over x. So then du is equal to -1 over x squared, which is the same thing as x to the -2. Notice how that's going to show up as well. And then there's a dx on it. So, all right, cool. All right, let me help out some chemistry, but good questions, Nabs.
Well done! Well done!
Infinity times 0 is the number of times I got turned down when asking for a date. I'll let you guess which one won. Dude, when unstoppable force meets immovable object, dude. Oh, yeah. Awesome, Nabs. Yeah, you're welcome, dude. I'm glad that helped you out. Feel free to join our Discord and stuff if you want. It's kind of another way to keep in touch and find out when we're streaming. Also, yeah, if you're watching us right now and you want to know when we're streaming, again, if you go to that website, thatactualdiscord.com/submit, there's also a link here for our streaming schedule. And so this will tell you all the times during the week we're streaming if you want to get help and I'm not here. Have I ever studied DiffyQ? Yeah. I haven't done any shorts on it, but I've definitely studied DiffyQ. Yeah. Okay. Let's talk about Max here. So Max says, naturally occurring chlorine is 75.53% chlorine 35, and the rest is chlorine 37. What is the average atomic mass which should be placed? Very cool. This is where I wonder, like, how exact do I have to get? Am I allowed to just say that this has an atomic mass of 35 and this has an atomic mass of 37? I think I am, right? Because, like, the electrons are so insignificant, right? Yeah, this is a weighted average. Okay. So if the rest is chlorine 37, this means 100% minus 75.53%, which is equal to 24.47%. Check my math. I think I'm good. Is equal to this. So you end up doing what's called a weighted average here, Max. So you're going to say 0.7553 times 35 plus 0.2447. Jesse, we need to cook. Yeah, Jesse, we do need to cook. Times 37. Yeah, if this whole YouTube thing doesn't work out, dude, I'll just go to, like, street chemistry. The rate at which I pull girls is like 1 over x. Just take the limit as x approaches infinity. I love these self-deprecating math humor jokes. They're great. Okay. So we just got to do some math here, right? We like math. Math is great. 0.7553. Right. Yeah. Times 35. Plus 447 times 37. So it should be 35.489. That should be it. And that's in, like, AMUs. Yeah, so approximately 35.49. Yeah, Jeff, dude, you wanna start answering student questions when I'm not here? When are we gonna get you to start streaming, Jeff? This helped too? Sweet. Okay. Right. Okay. It's the same thing for this. I assume you know how to do that, right? This would be like 0.9092 times 19.99 plus 0.0025. So this is sometimes confusing, and I can understand why. You have to move the decimal 2 places to the left. So you got to go 1, 2. And that's why this has to go 1, 2. You get 0.0025. Jeff only takes thermodynamics questions. Yeah. Yeah, dude, let's just blow up Jeff's inbox with physics questions. He'll be so happy. Wait. 0883 times 21.99. Yeah. Do that. You'll get the right answer. Nice. Thanks for the question, Max.
Well done! Well done!
All right, let's see what else we got. A couple up here. Next one's from Dead 5G. Which Dead 5G? Did you leave? I think Dead 5G left. So wait, I'm gonna skip that one then. Unless you come back, Dead 5G, then I'll do it. Let me get the next one here. A fish. Okay, let's see what we got here. I'm much more successful at annoying streamers. I don't know if I don't know if I want to branch out. Yeah. When you're good at something, don't do it for free, man. All right, let's see what we got. All right, a fish is rising vertically upwards towards the surface of the water at a speed of 3 meters per second. It observes a bird. Diving down at 9 meters per second. The actual velocity of the bird is given mu equals 4/3. Wait, what is mu? Excuse me? I don't know if I need to know mu. Is there something where like light travels slower in water? I don't think so. Yeah, I think if you're going up at 3 meters per second and you observe something coming down at 9, it's in reality coming down at 6. But that's not one of the answer choices. Fuck. Oh dear. Oh, there's also Fresnel. Oh, dude, this got tricky all of a sudden. Okay, I got to go learn about Fresnel diffraction. Cool question. I love when people do this to me, though. Right? Let me go find it. Yeah, the M over S. Yeah, I agree. Here, we're gonna ask it to just give ChatGPT to teach me. I don't know what the mu factor is. I don't think I've seen that. That's cool, though. Oh, it's optics. Oh, you're right. Someone did say this was an optics question. Oh, okay. An observer in water sees vertical distances magnified by mu. Oh, okay, cool. It's the mewing factor. God damn it. Right. So the fish is going up at 3. And then it observes UVB. Oh, I see. Okay, cool. That's kind of cool. Okay. So I see things 4/3 more than they're supposed to be, right? Is that kind of what we're saying? Right? So even though... So what I observed being 6 meters per second is 4/3 of what it should be. So, yeah. So 4/3 times the actual VB is equal to 6. So then all you got to do is just invert by multiplying by 3/4. This goes away. And so you get VB is equal to 4.5. Cool. Right, which is answer choice C. Nice. Does that make sense? I am Anoi. Would you explain the physics behind that? I actually don't really know, honestly. Why is that? Why is this? I think what it has to do with is that you're kind of creating like a lens with the water. Yeah, it has to do with refraction. Yeah, a viewer in a denser medium looking at something in the air sees an object further away than it actually is. Oh, interesting. Light bends at the... Yeah, I know about this. Light bends at the interface to the underwater observer. The light seems to come straight, so the brain places it at an apparent position. Uh-huh. Yeah, that's cool. Yeah, it has to do with this. Yeah. Why is it in the book at the first place? It has to do with this. Yeah. So, for instance, yeah, one second. Let's just pull this up. So, Yeah, the person in the less dense medium sees it closer than it actually is. Whereas the opposite is true, right? If you're in the more dense medium, you see it further away than it actually is. Yeah, this is also why we see the sun when it's geometrically below the horizon. I agree with that, yeah, for sure. Okay, cool. Perseus. So here, let me mark 2 as being done. Okay, I think this has to do with stats. I think it's a stat question. Okay, says, which of the following density curves has mu equal to 0 and sigma equal to 3? Okay. Okay, so this is the mean, right? And this is the standard deviation. Pretty obvious. Yeah, but let's see why it is, right? So, if sigma is equal to 3, right? That means that plus or minus 3 needs to be equal to 68% of the data, right? So, looking at this, right? Plus or minus 3 would be like right here, and that's like 100% of the data. that's like everything, right? Whereas this, yeah, this probably takes into more account like 68% of the data. What the sigma?
Good job.
Right. So Perseus, yeah, if you're watching still, I think that's why this is what it is. Yeah. Cool. All right, let's mark Perseus is done. I got Sonoma. And then let me see. Wait, is Equity watching? Sorry, Equity. I meant to add yours real quick. Equity, are you still here? This stream is very educational. Yes, thank you, dude. It is called actual education. Who would have known that this stream could be educational? All right. Great cross section of so many little snippets of different things. Yes. What's up, Equity? Here, let me do yours. Okay. Use the sets of here's more math, Jeff. Jeff, I'm relying on you here for some math help, dude. Here we go. Answer the question: is the set a group under addition? If not, specify which group properties do not hold. Set theory. Yeah, I don't know this. So, or group theory. I think if it's a group under addition, it means that groups are closed. Okay. Associative. But this says just addition. I believe if a set is closed under addition, it means like A plus B can equal anything else. In like, you can take the sum of two numbers to get any other number somehow, right? Yeah. So I think this is true, right? Okay, but the inverse of 2 is not in the natural numbers because it's -2. Amon, yes, I did. Amon. It was this. This was yours, Amon? We talked about how, like, the answer should be 6, but because you have this diffraction coefficient called mu, any result you have to, like, divide by that mu. Because you're seeing things move quicker than they actually are. So, is the set without 0 a group under multiplication? You'll watch it? Okay, cool, Amon. Yeah. Yeah, it'll be in the VOD after this closes. I did it recently. Oh, it's 8 questions per question? Oh, ew. No. I don't want to do that. By the way, you can just write yes. Okay, cool. Because wait, everything multiplying works out too? Even irrational numbers? Can I get an irrational... Refraction strength. Sorry, not diffraction. Yes, good. Diffraction. Yeah, diffraction is for, like, the slits. Okay, but then I don't know what this means. Is the set a field? You have to give 8 answers. Oh. You can't write yes? Well, I mean, Jeff said I think I can write yes for this one and this one. Because I think... But, and then this is the next thing we gotta do. This is complicated. Dude, equity, what are you taking, dude? What's this fancy-ass math you're taking? Jeff says, no, you can't. You need 8 answers. Do I need 8 yeses? Do I have to say this? What? A, B, C, D, E, F, G, H. So, natural numbers, a group under addition. Oh, yes, my favorite band. Okay. Oh, you figured it out? Okay, cool. Well, I kind of want to figure it out myself because I kind of want to learn it, but I'm also running out of time. Because the inverse of 2 is -2, and that's not natural. But what does that have to do with addition, by the way? Sorry, Jeff? I thought addition is just like adding numbers together. What does inverse have to do with that? Oh, to be a group, the additive inverse must be there. Okay. Oh, okay. Okay. Yeah, I gotta run because I got another student I gotta work with. But this is cool, equity. I like these. Let's see. Who else did I have on that I wanted to get through? Dead 5G we didn't get through, and then Sanuma. Here, let me see if I can just answer one of your questions, Sanuma, real quick. The second screenshot is this one. Prove each of the following. Even integers are closed with respect to addition. Odd are closed with respect to multiplication. Rational numbers are closed with respect to addition. I mean, even numbers plus even numbers get you other even numbers, right? But how do you prove them, Jeff? Here, explain to equity how you prove them. I'm going to do this next question real quick. E plus E equals E. Okay. Let me see this real quick. Okay. As P increases, so does C of P. Give one reason why this is reasonable. You can look at what, like, C prime of P is. Or I would say, like, DC dP is. In that case, that's 1/2 times 3p minus 15 to the minus 1/2 times 3. And I believe this is always a positive number, right? Because now you got 3/2, 1 over the square root of 3p minus 15. And I mean, yeah. So this is always positive. So long as P is greater than 5. And then, oh yeah, so here you go. So domain is P must be greater than or equal to 5. The range, so the smallest this can be is 0 plus 2. So that's 2 to infinity, right? So here we say 2 to infinity. If the retail price is 8, what is the cost to manufacture the part? Square root of 24 minus 15 is 9. Square root of 9 is 3. 3 plus 2 is 5. The cost of manufacture is 10. So that means that's 10 is equal to blah, blah, blah. So minus 2, that's 8 is equal to blah, blah, blah. Square both sides. 64 equals 3p minus 15. 3p equals 79. So 79 over 3. Is that anything nice? I don't think it is. Wait, it is. Because 3 times 20 is 16. 3 times 20 is 60. And then I need another... No, it's not. Okay. 79 over 3. Cool. Alright, Sunuma. Sorry, I wanted to do that real quick, but I do have to go run and teach some of the students. So, okay, cool. Alright, with that being said, let's close out the stream. Alright, thank you everyone for coming to Actual Education Office Hours today. Really appreciate all the questions. We are going to have a stream tomorrow. That's going to be an hour later. That will be at starting at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. Let us help you out with your math and science. If you ever want to figure out when we're streaming, there's this cute little website we made, and you can go to the streaming schedule, and that'll tell you all the different times we stream. And so you can see we're going to stream on Wednesday. We're also going to try and stream on Thursday. So, yes. All right. If you're following us on Twitch, which you should be, because Twitch is a lot... It's a lot nicer way to watch this stream because it's horizontal, and you can like see everything. You can also click here on the watch live on Twitch. Follow us there. And if you want to interact more with us, please join our Discord. We give out a lot of free prizes and motivate students to do well in their classes. And you can play video games with us and have fun. But if you're watching us on Twitch, I'm going to go raid someone. Thank you, Sib. Appreciate it. Let's see, we're going to go raid. Raid a channel. Who am I following? Who's streaming? Let's see. Mr. Aegis, Tina Kitten, Uo's Lab, Jinxie, Nerduino, High Potential, Professor Silfkin. That's cool. And Astra Canuck. I think I'm going to raid Nerduino because he's cool. Okay. Cool. All right. Enjoy the rest of your Tuesday. We will see you tomorrow on Wednesday. Peace.